Yo, good morning. Let's just jump right into it today. I want to get the chromatic aberration in place as quickly as possible so we can move on to some more interesting stuff. We experimented a little bit with it yesterday just to get it to look a little bit better. Or like how to specifically handle the outlines. And this was one of the ways. And what we can see here is that we have black outlines per chromatic aberration channel, which is a little bit too noisy, honestly. Yo, what's up there, Rick? Hope you're having a wonderful morning. So we talked about getting rid of the outlines for each of these and just have one in the middle of them, and it turned out to be a little bit more complicated than I initially thought. The good news, however, is that I think we have a solution, which I want to try, that will work. And I'm just gonna bring up the little note I drew yesterday too. So basically this was the first approach. We distort, and then we actually, this wasn't the first approach. This was the first approach. We distort, and let's see here. The distortion constant here decides where we read the different channels. I then switched to this approach where we read from the texture in a, or we, what is the correct terminology here, or better terminology? Well, we had the viewpoint, and then we have the refraction point, and then we rotated a refraction point or 3 refraction points around the circle, and that are the UVs for the different channels. Gave a pretty good result when it comes to chromatic aberration, but if we just want to have one outline done, and we want that outline to be located in the middle of the points, or in the middle of all the 3 different channels, if chromatic aberration is at max, we get the center point of a triangle and the outlines were just static. So what we eventually arrived at is this here. So we have the view vector, then we refract that one and get the refraction point. Then from the refraction point, we basically refract again once for each channel. And how much this refraction is decided by chromatic aberration strength. And then we rotate, and then we place the 3 points around a circle around this one, and then we can have the outlines on the middle point. I'm pretty sure this is what we want to do. The hardest part, I think, is gonna be or the point we need to think about one step extra is the secondary refraction. Like, how do we actually want to do that one? I would say that, okay, so if this is the view vector, we go down here, this is the refraction vector. What we would like to see is a refraction vector like this, and then we take this one and we rotate it around this one instead. So here we can see that I visualized rotating the initial refraction vector around the view vector, but I actually want to do a double refraction and refract the second one. But I don't want to use refract for this one, so what I'm thinking about doing is I'm thinking about rotating this one based on this one. So we do an initial Fuck, is that what I want to do? I think so. Or yo, what's up, Sama? Good morning, good morning. Thanks for the reference you provided. No problem at all. Hope you found them useful. And thank you. I hope I slice through today's problem swiftly as well. I'm a little bit worried that if we take too many shortcuts calculating this secondary refraction direction, then we're gonna get a uniform result that doesn't look that good. Let's just take a look at the code real quick again. Refract here, normal world space. I mean, we could take, like, the easiest way to do it is to just add 4 different values here. But I'm not too sure. Like, that didn't really give the result I wanted. I think this one gives the best, honestly. Yeah, I think so. Rotating it, I would say. If we take a look at the grid pattern here, I think this gives the best one. Yeah, let's do the secondary refract, but we don't do it by refraction here, but rather with rotation for this one. And I want to rotate around. So if we have a camera, how do I want to draw this? Okay, if we have a camera that looks in this direction, and I think I want to refract it given this one, so the camera tangent. And the amount we rotate it around this one is decided by chromatic aberration strength. So let's see. Let's do this and this. Okay. No, fuck, we wanna refract using tangent world space, I think. Fuck yeah, we do. So let's send in that one as well. Tangent world space. Ooh, that's true. How is that actually done? If we... let's see. We get a normal, but I would like to have... I guess we could do it with this one. Let's see here. Util math. We could probably do it with generate tangent here. Yeah, I think we're gonna rely on this one. So it's pretty much gonna be semi-artificial tangent. So do normal world space float 4, 3. Generate tangent, we use normal vs and epsilon 0.01 maybe. Then we send in the tangent here. Try refract. And then we do refraction direction world space. So we do refract. Nah, we're gonna add a. Let's do it like this: float 3 chromatic aberration direction world space is equal to rotate around axis we have an angle here which we're gonna do chromatic aberration strength times how I'm guessing we probably want to go 80, not 90 degrees. 45 degrees is probably too much as well, but we can start with 45 degrees. Pi. And then we have the vector we want to rotate, and that is going to be the refraction direction world space. And then we have the axis, and that is going to be tangent world space. Okay, so now we have the second one, and this one we want to rotate around this one for each here. And we always want to do 120 degrees, so we're going to do float Actually, chromatic aberration matrix, but we don't want strength here. 2/3 of pi, 2 pi 360, yeah, that's correct. And we want to rotate around refraction direction world space. So for each iteration in here, what we're gonna do is we're gonna rotate, so chromatic aberration matrix times chromatic aberration direction world space. Yes, like this. So here we rotate it 120 degrees, next time we rotate it 120 degrees, and the third time we rotate it 120 degrees. And then we have position world space, refraction direction world space. Here we want to do this, refraction strength, refraction position. Yes. Okay, this looks to be all right. Let's see what kind of result this one gives. Okay, this looks good. Let's see, what do we have? Chromatic aberration strength. This is pretty much equal to the normal one, right? Oops. Let's pause that one real quick. I just need to add tangent here as well. So we have this. Is there a difference here? No, there's not. Okay. And then if we add chromatic aberration strength, it looks like this. And I think this is... Honestly, I think this is perfect. Yo, what's up, Ray? Looking good. Thank you. Appreciate it. Yeah, the thing with chromatic aberration is, someone said it yesterday, less is more. Fuck, 45 degrees. Let's do less is more, so we're probably never gonna exceed this, I suppose. But I want to try and get... Let's see here. When we rotate around the tangent here, 0.25 pi, let's go 0.5. How does that look? If we can go real crazy with it. Yeah, that screws it up. Okay, so the only backside is that we can't, like, this is probably the furthest we can go, and it starts to look a little bit whack, but I'm okay with this because we probably never want to go more than this, honestly. Let's just see. I just need to take a quick look at the shoes here, or at the legs. Okay, we have that artifact. I'm wondering. I think it looks better. And now we're gonna remove some extra outlines as well. I think it can look much, much better. I think this is the chromatic aberration I want to go with. I'm just wondering, is it a little bit too colorful here? There's... let's try and fix the outlines then. So what we want to do with the outlines is... the outlines we want to use refraction, direction, world space here. So for the outlines we're gonna do actually we can just do this, I think. UV test single, and then we do UV test here. There we go. Ray, could you check the depth and have the chromatic aberration increase the deeper it gets? Hell yeah, we could do that. I think that's a pretty good idea. We already have blurring by depth, so it should be pretty straightforward. Now I'm pretty sure this is the chromatic aberration we want. This, I think this is beautiful. I think this is perfect. And if we go... I'm still gonna... I think we're gonna do... I'm gonna show... we're actually gonna make a shader variant out of this, because this went... we flew through this pretty much, so I have some more time to put into this. So we're gonna make a shader variant. You will be able to select what type of chromatic aberration approach we want to take, and then I'm gonna record. I think we're gonna have 3 main chromatic aberration approaches, and then I'm just gonna make a video of all 3 and post them on my social, see if people have any strong preferences, right? Because this one is the one that looks the best so far, I think, but it's also the one that, like, we have moved away from what's physically correct, and I mean, that's not very important to me. I just want it to look good, but we might lose some small details I haven't thought about by going the non-physical route, if you know what I mean. Yeah, this is definitely the best one. Let's add some more water here, by the way. Yeah, this looks great. On to water reflection, right? Maybe not today. We can see here. I think we're gonna do this one today, and if we can get this one implemented, that means that we have every effect below water surface is implemented, and then we can move on to water surface. Normal map panning, I think we already have this one, by the way. And here we have reflection. So yeah, But first of all, I'm just gonna add some shader variants here. Let's take a look at grass shader. So we're pretty much gonna add one of these again. Shader feature, keyword. Oh, we actually have that in the water, so we can just copy from that. Let's see. Here, keyword. And then we do what fidelity? I want to call this one chromatic aberration. Approach. Is that how you spell it? Chromatic aberration approach, or maybe. How does it look if the camera goes underwater currently? So not that good, honestly. Yeah, it's rough, but we have that as a task eventually. Yeah, this is universal render pipeline. Physical. Is this how we want to do it? Physical. Circular. Circular. Mean. Not too sure about these names, but yeah. Chromatic aberration approach. Yeah, fuck it. Let's go with this name for now. I'm a little bit unsure about the naming here, like how it works. Toggle, here we have this one. I like this the best, but for I'm gonna have to look into this one off stream, but for now we're gonna call this one chromatic aberration approach. Physical. Circular and circular mean. Okay. Luckily, it's only this method we need to change based on these different ones. So let's see here. UV test single, UV test. We're gonna do float for UV refracted outlines. No. Oh, yeah, outlines. It's a 4, and then we do if def chromatic circular mean. Then we do this and this. Elif Elif UV refracted outlines is equal to UV refracted, but if it's circular mean, or actually Elif chromatic aberration circular, but we're gonna have to do let's see, let's start with this. And here we do UV outline is equal to this. And then we do this. So if we have circular mean approach, then we just take the center value, and that is our UV refracted outlines. If we just have circular, we just put the outlines to be equal to UV refracted. Like this. Let's see what we have. Cannot convert from float. Oh yeah, float 2 here. Reading uninitialized value at 340. Is that so? 340 uninitialized value. Oh yeah, we don't have let's just add one of these for now, else UV refracted outlines is equal to UV refracted as well. Okay, so this is physical. This one doesn't do anything differently right now, but then we have circular. And what we see here, so just circular, this one creates outlines per chromatic aberration. Extremely noisy, but I'm not entirely sure how I feel about this one just yet. I like it a little bit, and maybe we could improve it a bit as well. So make the outlines for the red still black, but a little bit darker, or a little bit more red, and the blue a little bit more blue, and so on. But yeah, so this is circular, and then we have circular mean, which is 398. Do we need to do... This is probably not the correct syntax. Unexpected, yes. Can we do new float 2, 4? New... What? Okay, I guess we could do it like this, honestly. Can we do it like this? Okay, this. There we go. And then we do... So... Circular mean. This one is noisy as hell, but far away it looks pretty good, I think. But this one is probably way better, right? Okay, let's get the physical in place as well, so we can compare all three of them. This one is a bit... It's going to include doing a few more stuff. So when it comes to the physical one, what we want to do here is we don't want to utilize these. We want to utilize this one. Okay, these two are circular related. This line is circular related, so we could probably do if def circular, or that's how we can do it, like with, yeah, I think so, circular mean. So if that is true, and if yes, and then it's this one as well. So what I'm gonna do here is we're gonna do if def physical, then we do something else, and if so we want to do this if it's not physical. If it's physical, however, Actually, we can do it like this. Or can we? No, let's do it like refraction, direction, world space. Float 3. Chromatic aberration, world space is equal to chromatic aberration direction world space is equal to fuck, I don't think we care about this one here, honestly. One sec. No. Okay, so what we do here is we do... But I still want to define this one, I think. Do I care about that one? Yeah, I do. Float 3, chromatic, this one is equal to refraction, direction, world space. Then we don't need to define it again here. So if it's physical, what we're gonna do is we're gonna do this one. Water refraction index here, it's gonna be I minus 1 times chromatic aberration strength plus water refraction. And like this. So chromatic aberration direction is calculated like this. For physical, if we want to do circular or circular mean, we do it like this. Let's see what kind of result we get from this UV refracted outlines. 395. Oh. Okay. Let's see here. What can we do? fuck it. Let's just do it like this for now. Okay, so what do we have now? This is circular mean, circular, and physical. Fuck, is this actually physical? It looks pretty damn good. Except for the fact that blue... It looks like blue is static currently, so that's not good. Outlines as well. Why is that? It shouldn't be. Refraction direction. If it's physical, we refract. View direction, world space, normal world space. I -1 times chromatic aberration strength plus water refraction index. This one I don't, let's see. Refraction index is at 1 and we do, yeah. Yeah, definitely like circular more, honestly. Definitely. Okay, yeah, so if water refraction index, what? 0.75. If we get to above 1, it's not gonna work here. Yeah, that's the problem with this. Because if we calculate it like this, okay, so each color channel has its own water refraction index, basically. It uses this one by default, but we offset it with this. We can get above 1 in some cases here, and if we do that, yeah, we get a shit result, basically. So that needs to be handled here. But let's not worry about that just yet. If circular, we do this. If def, circular, otherwise we do this. You can see physical here it gives results like this. So if we look at this angle, we don't get any chromatic aberration. If we look at this angle, we get more chromatic aberration, and that's actually an effect I like a bit. While if we compare to circular mean, for instance, we get a little bit more here. Actually, I like circular mean the best, I think. Pretty sure. Although this triple outline has its charm, I would say, even though it's extremely noisy. But yeah, it feels great to have the option at least. Well, I'm undecided, so it's great to be able to switch between them. But let's see here, is everything yeah, we have the problem of, we still have the problem of going to, with the physical solution, we still have the issue of going too high here, which yields, actually, yeah, which yields this artifact right here. Yo, what's up, Cornucopia PC? Sorry about the pronunciation, but thank you so much for the raid and the follow. Appreciate it. And hope you had a wonderful stream. Yes, we get a static blue here. If the, let's see here, if the water refraction index becomes greater than 1, we get a static blue channel here, which sucks. But yeah. Derek, it'd be cool if the outline was there for all the colors but tinted towards the color of the refracted channel. Couldn't remember if I said that yesterday. Yes, I agree. We actually touched on that a little bit yesterday. The problem, or the hardest part, is that we're working with a black outline. So basically it's the opposite of how colors are blended usually. Like, because I agree, I think that would be very nice. So that means that the red channel would have red black outlines, the blue channel would have blue black outlines, and the green channel would have green black outlines, right? But when they intersect, you still want the color to become black. But if you blend them with high separate channel values, it's going to become more towards white or gray. Does that make sense, what I'm saying? So yesterday, I think, I don't remember at what hour, but we actually tried with white outlines and coloring the outlines according to the color channel, because then you get the correct blending. But yeah, it's a great idea. I just think, like, the implementation is going to be more complicated than one would think. So I think, I want to do it. If I'm just going to finish this physical here, and then we can just explore it quickly, see if we can come up with a nice solution how to properly blend it with colored outlines. I think it's a great idea. Okay, chromatic aberration strength. If we get above 1, we're fucked. So I wonder if we just want to... We could just do it... Chromatic aberration. We could just take the easy way out and saturate this one, i.e. clamp it between 0 and 1. And we get this. Okay, so this is good for physical. I think we're happy with this one. So once again, let's go through them real quick. We have, let's pause it so we can see the difference quick. So this is the physical one, only one outline. Then we have circular with multiple outlines. Something like this, and then we have circular mean, so circular with only one outline, and these are the three we have currently. Each, I mean, they all look pretty good, honestly, if I'm gonna be honest. Derek, so it needs to be some sort of subtractive tint that blends together properly. Sounds complicated but interesting. Yes. So yeah, let's explore it real quick. I think it's a great idea, and I want to see how it looks. So it's in we're gonna do chromatic. It's when we add them here. So basically we did it yesterday. Here we did it. Fuck, we already have it pretty much. Yeah, I think it should be enough by just doing this. So you can see what I mean. Circular, and then we do forward render. We switch the outline to white. So with this calculation, so here we have the correct outlines, or we have them like this. We would, so this is, or so in this example, we color each outline by its color channel, right? When they blend, they become white, which is not what we want. So what we want to do from this point, what we want to do is we want to bring down, first of all, we want to make it work with black outlines. And when they overlap the different color channels, we want to blend it towards black instead of white or gray. So we would need to do didn't we? I think we did one minus here. Okay, so if it's pure black, that doesn't work either. What we want to do is, fuck, do we just want to do, this one is 0, this one is 0, this one is 0. Maybe we want to do 0.5, 0.5. Okay, so here we have them colored as their different color channel. That's pretty neat. One sec, however. Blue doesn't seem to distort that much. Or actually it does. .75. It doesn't seem to distort as much as, yeah, and if we blend it, we get white or grayish, which is not that good. But yeah, this could probably be real nice if we could get them to blend to black. This could probably be my new favorite. Yo, what's up, Calvino? Yeah, it's a little bit too early for LSD Simulator indeed. But we would like to go even darker here, so 25 maybe. Wow, 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 wow. Fuck, this could look real nice. This actually already looks quite nice. But yeah, we get gray when they overlap, right? And that's what we want to fix. We want to make them black if they overlap. I think what we want to do is we want to make them darker the more they overlap. So I think we could pretty easily do it by doing something like this. Let's see. s.outlinecolor.rgb multiplied with one minus s.outlinecolor. Let's see here. I don't think this will give RGB divided by, at maximum we're at 0.75. What would this yield? This doesn't. We could do this. Divided by 3. So what does this? 0.33. Okay, so if it's only this one, it's 0. No. Fuck. Or if this one is 0, this one is 0, this one is 0, then we get white, but then we probably have an alpha of 0, so it doesn't matter. If we only have red here, let's say that this one is 1, then we get 1 divided by 3, 0.33, we get 0.66. Maybe not as dark as we want it. If all of them are white, we get 1, 1, 1 divided by 3. Let's see. We get white. Wait, one. How? Yeah, of course. We need to do times is equal to. Yes, because this alpha is. Yeah, that's true. One sec. I did the wrong thing here. We want to do 0 R R R. Two like this, I think. Not really, but getting close, I would say. Okay, so some blend adjacent to this. That's what we want to do. No. Actually, fuck, I think we want to do... If this one is bigger than 0, bigger than 0, bigger than 0. So if all three colors overlap, then we get black. If 2 overlap, then we get 0.33. Or do we? Yeah. And if only 1, then we get 0.66. Right? .66 is a little bit too... One sec, what am I missing here? 1 minus... Okay, so if we have red outline, we get 1, 1, 1. So 3 divided by 3 is 1, then we do 1 minus 1, and then we multiply it with RGB. So why the hell are we getting white when they all overlap? What am I missing? This shouldn't be it. I'm pretty sure we want a -1 here, but maybe we don't. I think this can look pretty damn sick, but do we need to add? That should be okay as well, I think. Okay. Okay, I like what I'm seeing here. But I also want to add the option to... I also want to add the option to... Fuck, this is pretty sick actually. But I want to add the option to be able to select like how dark we want the chromatic aberration outline to be. And we can probably do it with 0.5 times 0.5 times 0.5 times. But this pretty much only works with black outlines now. But look at this. Is it too dark? I want to try this with the physical as well. Maybe the physical is the best. Yeah, it looks pretty good. Zero 0.5. Are we going too dark with 0.5? Maybe we want to go 75. That's pretty damn cool, actually. Circular mean. So if we do this now, let's see here. Circular has colored outlines separated. Circular mean has one outline not colored. And then we have physical, which is, so circular, both of these use the same algorithm. Physical use the more physically accurate one. And it now has outlines per. Fuck, I wonder, is this one the best? Oh, fuck, this is beautiful. This is fucking beautiful. How fucking good does this look? Honestly, I can't decide. But I think we're done with chromatic aberration now. I think we have 3 different approaches that all look good, and we can quite simply switch between them. So I don't have to do that decision right now. And as I said, we're probably, like, the default water is probably not going to feature chromatic aberration. So but okay. Let's see. Is it clean enough right now? Note pretty much assumes that the outline color is black? Question mark. Yeah, I think we're ready for a commit here. I think. Yeah. Okay. Let me just commit this real quick. Okay, let's see. Okay, there we go. Had to... Let's see if I could properly... Yeah, okay, chromatic aberration for outlines. Beautiful. Okay, let's start exploring this one then, I suppose. Okay. So let's see. I have one tutorial here in notes. Let's read through that one, see if it's good, or let's see what we can do about it. One sec. Okay, interesting. Finally moving on from fucking refraction and chromatic aberration to caustics. So let's take a look. Oh, beautiful. Real-time caustics, good. Already looking good. Physically accurate result, yeah, I don't care about that either. But like, I 100% want to understand pretty much everything that goes on here, because like the plan is to make this, we're making a very general water shader, and then we can dumb it down to make it stylized, so to speak. This is something. So when I've read about caustics or looked around on the internet, this is something I would like to avoid. But I don't know if we have the option to avoid it. Like, I would like my water object itself to have these. But yeah, we'll see. But yeah, that's true, because maybe let's see where this brings us and what we can do about it. Geometry of the scene in world space, we need to use world space UVs. Yeah. We will perform a reconstruction using the depth buffer. This is explained in the... So here is one thing from the get-go. I wonder if we can get around this a little bit by... Like, we actually have terrain data in our shader, so we know the ground values, but we don't if we have objects underneath. Yeah. Ray, why question mark, why what? Why I want to avoid caustic volumes. I wouldn't say my reasoning is logical, but I just want to avoid adding more objects. I like having it concentrated, if that makes any sense. But yeah, let's see what we can do. Reading the depth buffer. Yeah, reconstructing. Yeah, we've already read the depth buffer. We use it for separate stuff, so it's okay. And we do it in linear eye space as well, which I think should be okay. Maybe. But what the fuck? Like, this is what I don't get. This, I guess we're gonna get to it, but why can't I just use my water as this object? Honestly. But we'll see. Yeah, what I'm thinking here is... Okay, so far I think we can use the water object, and our mask is going to be pixels that are underneath the water. So let me show this real quick. So let's do... we have outlines to take into account as well. Would love to have caustics on top of the outlines, that would be amazing. But if we just do return 1, we get this. But what we want to mask here is we want to mask which one is the active scene water depth. So if we return, is it S, by the way? Let's see. It's S we work with, right? So I wonder, yes, yeah, S. So if we do return S dot scene depth is bigger than pixel depth, or S dot outline depth is bigger than pixel depth, then we return 1, otherwise 0. Yeah, which is 1 for all of these. One sec. Yeah, we get 1 on the outlines here as well. Yeah, like, so pretty much what we check here is when we render the water object here, it's not that visible here, but when we render this water object, we check if the pixel behind it is underneath the water surface. If so, it's white, otherwise it's black. And we do a depth check here, so it's not that visible. But I wonder if this mask, if we could use this mask instead. But let's see, there's probably a reason for volumes being used in most cases. The good thing with using... Oh! The good thing with using volumes is that the step to... So when the camera gets underneath the water, we're still gonna render the caustics. If we just rely on our water shader to do it, we're only gonna have caustics if you look from above the water surface down towards the ground, right? So if we go with volumes instead, if the camera goes underneath, we still have caustics there. So gotta keep that in mind. But then again, it all depends on how we chose to render the water when we're under it. I don't really know what approach we will take to that just yet. Direction of light, yes. Multiply world position with main light direction. Main light direction. We're probably gonna rely on util lighting get main light located in lighting.hlsl. So when we use the panner function here, I wonder if we want to sync it to the normal map of the surface. Probably do, right? And we probably want to get a better texture for this as well, but I think we're going to rely on Voronoi noise initially. I think. Do we have access to that in util math? Gradient noise. Yeah, we're probably going to rely on the shader graph for Voronoi noise. Let's see if we have that. If that's available to us. So far, like using the water object we have to render these caustics, the only downside I see of using the water object as opposed to a volume is that if the camera goes underneath the surface we don't see it anymore. But I'm wondering if I'm gonna start by implementing this in the water shader, but hopefully be able to implement it in such a way that we can move it to a separate shader if we feel the need to. Whoa. Okay, so just a random offset like this. Nice. Luminance. This one I've never seen before though. Sample scene color. We already have this one, I think. But okay. Okay, I wonder. Yeah. Let's start by implementing this in the water shader without a separate volume. See if we can make it work real nice. We can use a lot of things we already do in the water shader, so we don't need to read. I don't think we need to read more textures and stuff like that. And then we can make, fuck, I don't know. Then we can probably make, fuck, how does caustics and refraction work together? To the do we want, fuck, that's true. We can probably implement it in such a way that we initially don't let the refraction affect the caustics, but I think, fuck, do we want them to affect it? Or, like, if we take a look at, we're gonna experiment a bit, but okay, let's see here. Let's start by creating a texture real quick, and I'm gonna do it in the shader. I think we're gonna do Voronoi noise actually. Gradient noise, and we do so what do we have? Actually, how do I do such a lit? Why outfloat cells. Oh, we have 2 out. I don't care about cells, I don't think. So let's simplify it a bit. One sec though. Okay. Okay, let's see if we can rely on these. Let's keep cells. Unity Voronoi float. I wonder if I want to do it like this. Float. Generate Voronoi noise value. Float to UV. Float angle offset. Float cell density. Float Voronoi value. And then we do Unity Voronoi float UV angle offset cell density keep it like this for now. Terrain procedural water. Let's add chromatic aberration, water refraction. Caustics is eventually gonna play with both of these, so let's put it here. Ooh. Let's put it here. First of all, I want to be able to control the Voronoi texture because I want to make it look sorta like a real Caustics texture would look. So, what do we need? We need angle offset cell density. Caustics, noise. Scale. And then we do caustics. We're probably gonna rename it later on, but noise angle offset. I would say that we're gonna rename this one to something like so when we generate Voronoi noise, depends on if we're gonna keep relying on Voronoi noise or if we're gonna rely on a texture instead. But if we go with the noise solution, angle is pretty much how ordered the noise is. Let's try one here for now. What do we need more? Angle offset cell density. And then I want to add Caustics noise threshold, I think. Threshold. I think these are the three we can begin with. So let's put here. Okay. First of all, I don't really know where we're gonna put it. We're gonna put it as early as we can right now, and then we're gonna move it. So let's do it before refraction. Get scene information. Great, we need scene information. So let's put it here. Let's remove this one for now. Okay. So first of all, we need to get the world UVs. Which here was done by depth buffer we have already read. Compute world space position from NDC. We have the depth in linear view space, I think. So Unity shader variables, built-in shader variables. We probably just want to multiply it with in fact, don't we have it here? TMV. Let's see here, brings it from model to projection space, right? Brings it from model to view space. No. Model to world, world to view, view to projection, right? Or object to... Is it this one we want to rely on? Object to world, world to view, view to projection. So this one brings us from world to view space, so we don't want this one. I would like matrix TV. Because I want to rely on our scene depth here and outline depth here, which are currently in linear eye depth. Linear Unity HLSL U space to world space. Yes. Oh, camera. Oh, camera to world matrix. Do I have access to this one though? Let's try it. But yeah, we just have a singular value here, do we? Scene information, scene UV, sample scene depth, Unity near clip value and 1. Is that so? Painted by Varkimist. Varkimist for short, I guess. Yo, what's up? How are you doing today? Fuck, position and the C. In position in clip space. Compute world space position. I want to see, where do we have access to this one? We're currently working on water. Different effects for water. Right now we're doing caustics. Ah, beautiful. What I worry about is, oh yeah, we have core and depth texture, beautiful. And reconstruct world space position of pixels from depth texture, beautiful. Fuck, do I want to do... I would love real depth, so I guess this is for the reconstruction function compute world space position. I do want to rely on this one, but we don't have the depth value in normalized device coordinates, so that means that we're gonna have to add an additional depth value, and I'm not so keen on that, honestly. But this one is defined in common HLSL. Let's see. Let's see what it actually does. And what did we have? Compute worlds. Okay. It computes position in clip space. First, so normalized device coordinates, it brings it to clip space, brings it to view space, and then this. Warchemist, are you working in Godot? No, I'm using Unity here. Okay. Fuck. Okay, can we minimize the damage? Position NDC. Okay, what if we calculate this one? Linear eye depth. I mean, eventually, I wonder. Oh, world space position, there we go. Is this actually? I think we do it a little bit differently, don't we? UV. Input position in screen space XY. So this is. So this one we might not need to do, but this one is the biggest problem. So when we calculate our scene information here, we do outline depth, Fuck him. I have to add. Probably gonna go with adding VS, VS, and then add a separate depth. The best part would be to work with depth in NDC. Is it NDC or clip space throughout this one? Maybe we can worry about that later. But before I continue, I just need to run. Oops. One sec. Let's do this. So. Okay, I'm just gonna run AFK real quick, so be right back. Okay, back. Sorry about that. So let's see. We're gonna do it in a pretty unoptimized way initially, I think. We're gonna add 2 extra values to this. I wonder, though. Or one sec. Let's take a look at sample scene depth. Okay, maybe we want to go to core then. And Fuck it. Let's do... One sec. Sample scene depth. Okay, let's... Sample... Fuck, we're gonna do it like this then. For now, let's just worry about non-chromatic aberration. So let's disable it. It's disabled. And jump down to this one. And we do float scene depth. Scene depth in fuck, I would like to do this. How many scene depth do... Oof. Scene depth... Okay. Outline depth VS, and then we add float, scene depth, float, outline depth. And we do it like this for now. And then we do scene depth vs. So here we do s.scene depth is equal to and here we do s.outline depth is equal to okay, so now we have the depth in the correct form of the depth. Position NDC, I think I want to see what happens if we just rely on the UV we have, so scene UV. So basically, let's see here, UV scene center. So what we do here then is one sec. Okay, we do pixel. No. Scene. Float 3 scene position in world space is equal to then we just do this compute world position. Did we have yeah, okay, we want to do the same thing. Like this. So now we have scene position in world space. And from that one we calculate the... let's render it, see how it looks. We want to do scene position, BS, and we want to multiply it with light direction. But we want to use get main light. We need shadow chords. We already have those, I think. Yes, we do. So let's get main light. I think this one should have the position. We will see. Or direction, I mean. I'm pretty sure. Light direction. So we could make this work with multiple lights eventually. Direction. Eventually. And then we want to sample the texture. We don't want to sample a texture, we want to recreate this one. So let's try real quick and do... let's jump to util math and let's see if we can make this work. Oops. Okay. Let's see. Yeah, we need this one up here actually. This should be correct. No matching Unity Voronoi float. At what line are we? 172. Okay, let's worry about out first. Unexpected token. Oh yeah. Yo, what's up, Sleepy? That is correct. Position NDC. Yeah, we want to do... I think I want to try with using s.scene UV here. Undeclared depth. Here we want to do s.scene depth. Invalid subscript. Fuck, did I name it? Oh, no. Did I? Oh, yeah. Okay, I fixed it in the chromatic aberration implementation. Let's do it here as well then. Float scene depth. And float outline depth. Okay, let's see. Josh, thank you for the follow, appreciate it. Okay, now it works, that's good. Let's see if we can read some Voronoi noise here then. And we do float. Let's just float. And then we want to do generate Voronoi noise value. UV caustics. Then we have angle offset cell density, and here we rely on noise angle offset and scale, and then we return this value. Let's see what we get. Yeah, I don't know. Actually, it bends beautifully. Okay, it bends. The noise itself is kind of fucked though. But what if we do noise scale? We only have it in one direction right now. Is that so? Why is that? Oh yeah. We want to do something with this here. We want to take X, Y, but that's still, that shouldn't really do any difference, or should it? No, I don't think so. Invalid subscript XY. Get main light. Multiply. Invalid subscript XY. Oh, yeah. What the hell? We multiply... Yeah, I forgot some. Float 3. What is main light direction in this case? So if we multiply a vector 3 with a vector 3, does this one return 1 value? Okay, so my main light direction is probably not the same. Okay, what do we have? Sun matrix. Okay, so main light direction in this case is a matrix. I don't know about that. Let's see. Unity HLSL. Get main light. Lighting. And let's see, do we have light? I want to get... that's not what we want. What are we working with here then? Get main light. Okay, we don't have the definition here, but then we get a light. Okay, so let's do Unity HLSL light struct. Here we do. Direction color. Okay, so we're doing half 3. Fuck it. Let's see if we have access to... I don't want to set more... I don't want to set these variables. I wonder if we have something available to us. Lighting, world stabilize pause, world to light. Yeah, this is what we want to use, right? Main light direction, Renaissance transform local to world matrix. Okay. One sec though. Local to world matrix. Yeah, okay. So this is a matrix that brings it from object space to world space for the light. And that's because we want to transform this world position to... the fuck? This code will simply write the direction of the light to the appropriate shader property. I don't know. Okay, let's offset based on light. Not just yet. I wonder if we could... Yeah, I definitely want to avoid this. I don't want to set more... I don't want to add like dependency. That this is being set correctly, although it should be quite easy. I think we can do this in a different way eventually. But then again, a little bit of a question mark around this one. So world to light. And we're talking this one. Okay. Okay, so what we're doing here, I think, is we're bringing this one to the light space, right? By multiplying this is the same as transposing this, question mark. So we could do, if we would have access to, I'm not so sure we have access to these, honestly, since we don't include this one, but do we have something similar? Real-time lights, get main light. Common then, light, common. Fuck it, let's do world to light matrix unity. What the fuck? We should maybe. Fuck, did I close that one too quick? Maybe we could recreate it ourselves real quick. But there should be something available to us, right? We're gonna do light to world space matrix. Light space to world space. But I don't want to do that. Unity world to light. Yeah, I don't have access to this one, I'm pretty sure. But maybe we have something similar. Yo, what's up, Meister K? Thank you for the Prime. Appreciate it. Hope everything is well with you. This is one of the HLSL. Yeah, here's the thing. I don't rely when I write HLSL shaders. I don't rely on where do we have it? These files, but rather we use these. There should be something similar. Lighting.hLSL, we have that one open somewhere, I think. Okay, maybe not. Unity HLSL. Do we have anything here we can use? Okay, let's do world to light. Fuck, how come we don't have this one? Is it located in... Is it defined in real-time common shader? Do we have depth? Okay. That's unfortunate. Okay, let's do it like this. Let's jump down to here and we do... I'm still a little bit... let's do something like this. And then we do this. I'm still... Okay, if we don't do it in the light coordinate system, XY, then we have XYZ. We would probably like to transform this to light. Should I just take the jump and set it like this? But I think we're gonna set it as a global matrix. We're gonna do it like this. Fuck it. Environment controller. On awake, do we have light references here? No, we don't. So let's do... But what I hate with this is that, yeah, like, this is gonna work for the main light. I don't even know how we would do it for multiple lights, though. That's true. We would do it with a for loop, I suppose. But like this will work for the main light. But let's say that we add multiple smaller lights and we want caustics based on those as well. Then we're gonna get a problem since we do this with a global, or we do it this way. I would like to have... We're gonna solve it. We're gonna do... Let's do this. Util lighting. Let's add a function here, or a to-do. To-do, create function for calculating M matrix for lights. If we can manage to implement one of these, that would be very nice. I think it would be very useful for things other than this water as well. But for now, let's do environment controller. Let's do... now let's do light and sun, and then we do so what we do here then is we're gonna do is it graphics dot set global matrix unity. shader. Global matrix. And I want to name this appropriate because I think I'm a little bit skeptical. So basically what this is, main light direction, it's a local to world matrix. It's not main light direction, but I might be misunderstanding something. But what I want to name it to is, where do we have it? Something similar to this, yes, world to light, but that's not, we have light to world. Or actually, yeah, light to world is what we want, I think. Local to world, yes. Light to world matrix. And we want to do sun.transform.local to world matrix, yes. So in water here now we should be able to do, yeah, let's remove this one and do light to world matrix XY. Let's see if we have any problems with this. Okay, that's not good. But actually, yeah. Now we're gonna have to restart this. But we still have, I think it's still purple. Okay, let's see what the error is. Model no matching to primary. Undeclared identifier light to world. Oh yeah, of course. Or actually, one sec. We should have access to this one like this, I think. Or let's try. I think it's a float 4x4. I'm not sure. But then we're gonna have a mismatch, aren't we? Okay, there we go. But still not entirely correct. If we do XZ here instead, I think we're gonna, yeah, then we get this. But if we do XZ, If we do XZ, we're gonna get a weird result when we do, let's see, height, yeah, like if we have a vertical wall, I don't think we're gonna get a correct result like this. What am I missing? Or let's do now we get this kind of result, which is that's not good at all. Did I fuck this one up? Oh yeah, of course. One sec. Environment, we haven't set it here. So sun is okay, makes sense. Let's see what we have now. Okay, still. But, one sec. And then we do XY here. And then we do add a cube. What do we get? I think it's better. Yes, it is. Okay, beautiful. That's fucking great. Okay, nice. Now we can worry about what we want to do with this texture. Let's see. Angle offset. What are the values we have? If we have 0, we have this. If we have 1, 3.14, 180, 360. Is it up to 360 we want to go? Or is 1 and up? Yeah, 360. Or is 314 might be okay. Let's try it. Angle offset, float. Let's take this into a range, 3.14. So then we do, oops. Okay, that's great. And scale. I don't even know. Yeah, we probably don't want to go lower than 10 here, honestly. Range. 0 and 10. In fact, we don't want to go to 0 either, so let's do 0.01. 0.1. Well, that's too small as well. Probably never want to go smaller than this. Okay, let's threshold this one now. So let's do caustics is equal to I want to do a smooth step. Let's take a look. Or is it a smooth step? Yes, between 0 and 1. Yes. And here we want to do threshold X. Threshold Y. And this value. And let's see what happens if we bring this one up. It's a little bit rough, I would say. What can we do to avoid I don't think we it's these circular artifacts we get by doing this. But then again, if we do return float 4 caustics Oh, yeah. Fuck, of course. We do a manual blend here. That is true. We don't rely on HLSL blend, so... Do we have scene color? Yes. It might work. It just might work. 0, 1. It's pretty good. Okay. Yeah, this will work for now. I wonder, it will probably be cheaper as well to have pre-rendered textures for this, I think. But we don't care about tiling and stuff like that right now, so let's do we pan the normal map here by doing water normal map time multiplier times time y. We probably want to pan it similar to this one, I would say. I think. Yeah, so let's do UV caustics is this one plus this. Okay, and then we want to add a second one, which we want to pan over it. So we're gonna do this by minus, we're gonna do it like this. Noise, caustic noise scale. Can we do this? And And then we do cosine angle offset big. Small. Small. Might want to rename them, but whatever. UV caustics, giant for a noise value. We just do min between them. Okay, so caustics big, small. But then I wonder. Let's see here. Yeah, we want to do this differently. So let's take this one. Put it here. And then something like this. Okay. Okay. Where do we have it here? Angle offset 0.5, 3.9. This is not pretty. Oh yeah, let's go with 2.5. And let's do autonomous map minus 0.5 times this. It's rough as hell. Why? If we go 1 here. Yo, what's up, Diligence? I wanted this one screws it up a bit. Ah, it's not this one. Okay, great to know. That's better. Angle offset. Probably want to go a little bit smaller, don't we? 2.5. Oh, that's too small. 1.5, 2. Derek, I'm definitely excited to see it with some refraction, if that's something you're planning. Yeah, it is. But it's gonna be, hopefully the code is structured in such a way that it won't be too hard to get this to work with everything else, I think I have a pretty good way to do it. We're gonna bake it into scene color, because everything else uses scene color later on, and that includes chromatic aberration, refraction, blur. So we'll see. Diligence looks like a flat texture. Yeah, so this is caustics, so this is light refracting at the surface and ending up on whatever terrain you have underneath the water. So this is supposed to be rendered on the world, so to speak. Honestly, I sort of know what we're doing, but I have someone who knows what they're doing to guide me, so it's okay. And yeah, we can see here that our caustics it's way harder because we rely on Voronoi noise. Will the caustics cast shadows? No, they are pretty much... So this is not going to be located on top of the surface, this is going to be against the terrain on the bottom of the water. They will be affected by shadow, so we won't draw them as light here. But yeah. I wonder... Yo, what's up, Geralt? Amazing job, sir. I love it. Thank you, appreciate it. We're only getting started here. The caustics is a form of shadows from the water at the bottom of the terrain. I guess you could say that, or light hitting. So, like, the caustics effect is actually, yeah, it's now we're down to terminology. I don't really care about that too much, but yeah, it depends on how you see it. I wonder if we would like to add some like emission here. Some emission might spice it up a bit. But yeah. And here we have a simple chromatic aberration solution. I'm thinking of nah, I don't want to rely on this one. I don't think. We're gonna rely on our chromatic aberration. But to rely on our chromatic aberration, we're gonna have to get the refraction into play right now. So this is what we're gonna do. Let's see. When we create this stuff here, we calculate scene U. We're probably gonna bake the caustics calculations into get scene information here. Because what we're going to do is when we read this one here, we're actually going to bake the caustics into this one. Because then when we read this value later on, we get the refraction on the cheap, I think. Yeah, some soft glow would definitely improve it. So let's see here. I think what I want to do is we're gonna do this. Float, calculate caustics value, maybe. What do we want to send in? We want to send in fuck, this one is hella cheaper, I think. It's also a question of, do we want to support chromatic aberration on caustics but not on anything else? Ah, fuck me. Diligence, no, it's actually at the bottom. It's actually at the bottom. But it's a pretty flat. It's 100% getting deformed. So should be okay. But let's see here. Fuck, should I just implement... Maybe I should just... I think I want to rely on my chromatic aberration implementation initially. Let's try it and see what happens. So let's remove all of this. So we're back at this water, and do this. Calculate caustics value. We're gonna do a float 4 here. We want to send in a float 2 UV. And float depth. Change this to UV. Change this to depth. And then we smooth step. We might as well do this then. And then we do here sample scene texture color to the LOD plus, oh, no. I don't know if we want to rely on util blend. Right now we only have this very simple blend, mind you. So I think we're going to rely on that one, but I just forgot to do one thing here. Calculate caustics value. Let's bring this back, and then we do return yeah, let's do this for now. I might want to add some other stuff there eventually, but then we do, so here we do blend source alpha 1 minus source alpha, and we blend between this one and calculate caustics value scene UV. Fuck, it's gonna be a mess trying to get this to work with UVs later on as well. Maybe not that big of a mess. And scene UV, let's do S scene UV and S dot scene depth. Undeclared identifier. Yes, we need to define it first. Just have no worries, my sweet Swede. Nah. We're gonna manage this. I wonder if the distortion or the refraction screws it up more than it needs to. Maybe not. And let's see if we add it to the chromatic aberration as well. Fuck, we're gonna need to do a lot of cleanup up here to make this look pretty. But it's a start. Yeah, we probably don't want to rely on... We want to rely on a different blend function. This is the wrong blend for the purpose, I think. So that's one thing. Diligence, the caustics are uniform, repeating. It looks like the same pattern. Unlike the example you follow, you can't see repeating patterns. Honestly, I can't see any repeating patterns here. But I also stated that, so right now for the caustics, the visuals, we're relying on Voronoi noise and not a pre-rendered texture. So that will hopefully also improve the visuals quite a bit. But when it comes to repeats, I don't really see any repeats here, I don't think. We should actually have less repeats since we don't rely on a texture. Yo, what's up, Cooler SK? Yeah, you know it, you know it. Okay, let's see if we can get this with chromatic aberration as well. That would be sick. Diligence, humility, I appreciate you. Everything you made is 110%, thank you. But caustic so far is just average. What is the saying? Trust the process, right? We just started, my man. We just started. Okay, so what we're gonna do here for this one is we're gonna do this one here. This one, look at this shit now. So here we're gonna do blend source alpha 1 minus source alpha. We're gonna blend with this one. And we're gonna blend with float 4. This is rough as fuck, I would say, because each call to this method pretty much generates 2 Voronoi noise, I guess. Let's see how this looks. Okay, so this is normal without chromatic aberration. Will we get an error? Yes, we will. Cannot convert from float 2.4 to float. Not entirely sure I understand this one just yet. Let's see. Cannot convert from float. Oh yes. We need to do scene UV here. But then we also need to move this one. Incorrect number of arguments to numeric type constructor. Float 4, 1, 2, 3, 4. Okay, so what am I missing? Oh, fuck yeah. This one returns... Chromatic aberration. I don't actually see any on the caustics, do I? Is it because if we do this... Oh, sorry. 0, 1, 0.5, 0.1. Am I seeing it here? I wonder if this blur is screwing it up for us. Yes. And if we do circular mean? We can do it like this. Chromatic. Let's do 0.1. Physical. Actually 0.5. Yeah, it's honestly not that visible for the caustics. We can compare it to... One sec though. Have I forgotten to... No, I haven't. It's definitely not that visible. Not as visible as I would like it to be. Well, actually, it is quite visible, but it's getting obstructed by... So if we do ground... Yeah, it's visible now. But doing it like this doesn't yield the same... I wonder if we want to do individual chromatic aberration on the Voronoi noise, actually. Definitely want to try, see what kind of difference we get. One sec. Never mind. Oh, yeah, we can't rely on this. Fuck. Or can we? We should be able to rely on this. One has to remember here that we don't have any surface light calculations right now. So at this point we shouldn't be getting caustics on the floor at all. What am I missing? Oh, is it because of deep color? Yeah. Okay, 75. I definitely want to try individual chromatic aberration on the caustics, that's for sure. Let's try it. So I want to do... test flag A. So we do guess we could take our It looks a little bit nicer, doesn't it? I wonder. And I wonder what happens if we do... No, actually not too sure about the chromatic aberration doing it like this. The good thing is that it's not tied to chromatic aberration on a character, which I guess I would prefer. honestly, I think I definitely want to use... I want to see what happens if we do... like, I would like to offset this Voronoi noise by the surface normal map as well. One sec though. How would this look if we do that's not the one. Plus time. Because right now we have the Voronoi. Oh, one sec. Okay, the Voronoi is being refraction. We have refraction on it. It's just that it's not that much. Or the texture or the noise itself makes it look like gas. A lot of improvements to be made, but I think we did some very nice stuff today, especially with the chromatic aberration. I'm gonna post the different chromatic aberrations online and just get a feel of which one people prefer. But I gotta run now, so we'll continue this tomorrow, hopefully make it look nice. Thank you so much for watching, everybody, and have a great rest of the day. Peace.